Graph the function. The first thing I need to do is what? Amplitude period, always a good first plan. Amplitude is 3/2. The period is pi. Any questions about that? Where did I get pi from?
2 pi.
2 pi divided by that 2 in front of the x. What do I need to do next?
Find out before it goes to the left.
And how am I going to do that? And what do I need to do before I just look? I need to factor out that 2. That's the format I'm used to seeing it in, so I do need to pull that 2 out. So I get 3/2 sine of 2 times x plus pi over 4. Everyone agree? Pi over 2 divided by 2 would be pi over 4. So I'm moving left pi over 4. Any questions so far? So, I'm going to plot this. My period is pi, which works out nicely. That means the 1 tick mark is pi out over 4. That'll be nice when I'm plotting. We did some yesterday or Fridays that weren't so nice, so they could turn out like that, but we like the ones that turn out nice. And so just stick with the sign for 3/2 is 1.5. Sign starts at 0, 0, goes up to 1.5, back down to 0, down to -1.5, and back up to 0. And that is 1 period of sine without moving it left. We are. Any questions so far? I'm going to pick it up and move it left pi over 4 units, which is 1 tick mark. So the green graph is the final graph. Did it say how many periods to graph it over? Okay, so what I've done is I need a graph from -2 pi to 2 pi. Now, in fact, I have quite a bit more to do, don't I? So let's do it. Now, you could have graphed more to begin with and then erased back, and some of you may prefer to do it that way. But I need to graph over all of those tick marks there. If you happen to have already graphed 1 period, I probably wouldn't go back and redraw the red graph bigger. You could, but I would probably just look at the pattern on the green graph and go from there. Does that make sense? It's up to you. You have options on that. Okay, so that's to 2 pi on the right. I need to go back to -2 pi. See how I'm doing this? Just repeating after that. Okay. Any questions about that? Does that help with homework questions? If you did need a quick refresher. The only thing we didn't do was a vertical shift. We did need to do a vertical shift. Pick that up and move it up or down over 2 units. Good talk. Okay, so today we're going to look at some things we can do using trig functions, some modeling using trig equations. So I want to remind you of a couple of things we learned. To find an equation, there are a few things we need. We need the amplitude, we need the vertical shift, we need the period, and we need the phase shift. Those are the big important things we would need if we wanted to graph or find an equation of a function. Would you agree? Well, The amplitude, would you agree, would be half the distance from top to bottom? You'll want to write this down. From the highest value your trig wave takes on to the lowest value your trig wave takes on, it would be half the distance of that. You'll want to write that down. To get the amplitude. Probably want to write it down. No. Okay. The top value, which is not the period, the very top value to the very bottom value, half of that distance is the amplitude. So if we go back to the bell here, this is 3 over 2. This is negative 3 over 2. The distance between that would be 6 over 2, or 3 units. Half of that distance would be the amplitude. You need to know that. Just write it down. Write it down.
I did.
Okay. Maybe didn't.
Yes, I did. It's right there.
Half of what?
I don't know.
Just write number 1. Just write it down for now. But that's not going to mean anything to you later. Write this down. I'll show you an example in a minute. Write number 2 down. Okay. The vertical shift on the graph, as you know, it's that kind of distance to the center line. It turns out that would be the middle of the maximum and minimum values, right? Wouldn't it be right in the middle of the top and the bottom value of the sine wave? So if I look at a random sine wave and I have no idea where it is, the vertical shift would be the middle of the maximum and minimum, right? Questions so far? We know that the period is the time it takes to complete one full cycle. This could come from frequency. You haven't heard that word yet, so we'll talk about that word in a second. And then the phase shift is determined by where the wave starts. And we'll talk about that as we see problems. It's probably the toughest one. Any questions about this so far? So we're going to do some trig modeling 2 ways. We're going to do some by hand, and we're going to do some with the calculator. The calculator is what, if you were an engineer, you would use a calculator. So the by hand part is trying to get a grasp on what the calculator is doing and how that relates to what we're doing in the real world and how all that works together. On Tuesday and Thursday, we will do a project where we get a slinky out and we have our calculator model a trig graph from that. So that'll be kind of neat for you to see what that looks like when a calculator takes data and turns it into a trig wave. Today we're going to focus on by hand. And first, before we do any problems, there's a word you need to know, and it's frequency. Frequency is the reciprocal of the period. And let's talk a little bit about units. The period is the time it takes to complete one cycle, right? The time on the x-axis when the sine wave completes one cycle. The frequency, instead of time to complete one cycle, is cycles over time. How many cycles we complete in a certain amount of time. You've probably heard frequency before in terms of sound, and it's how fast those trig waves or those sound waves are. Again, we'll look at that in an example. So, here's our first example. Luckily, they give us the function for us, so we're kind of easing into this stuff. So the average temperature in degrees Fahrenheit in Phoenix can be modeled by this trig function. Someone tell me why yearly temperature would be modeled by a trig function.
It fluctuates.
Fluctuates, but what happens next year?
It stays.
It's about the same as this year, right? It kind of repeats the same average temperature cycle. Would you agree? The temperature next October in Arkansas will be very similar to this October in Arkansas, October after that. Now, of course, there's always a little fluctuation in that, but we could track temperature using a periodic function because it's going to change periodically. It tells you that x is 1 corresponds to January, x2 corresponds to February, and so forth. So this is what I would consider an easy trig modeling problem. They did all the work for us. They gave us the equation. Wonderful stuff. So part A. According to this model, what is the average temperature during the month of October? How would you find that? Plug in temperature. What should your calculator be in? How do you know? There's a pi over 6 in there, so it should be radians, right? So I want to see that pi over 6, I see radians. Now, what's in degrees? The temperature, right? So not the angle. The angle looks like we got a pi over 6 going there. You will learn why that's pi over 6 there momentarily. For now, we're just going to take it because it says so. So plug in 10, and what do you get? How does the result from part A compare to the actual average temperature in October of 74.6 degrees Fahrenheit? Let me tell you why this question's asked. Someone came up with this trig model, but then someone then actually found the average temperature in October. It doesn't make sense for them to be a little different.
Doesn't it make sense?
Does it make sense? It does, because is our model going to be perfect?
No.
Would you say that this is close enough to call it a pretty good model?
Yeah.
The average temperature was 2 degrees off. Makes sense that that would fit. So how does it compare? It's a little below. Right? Actually, it's a little above. According to this model, what would be an approximation of the average yearly temperature in Phoenix? Without doing any work, think about what that function would look like. Don't graph it. Think about it. What does it look like? Looks like a trig wave. Has an amplitude of 19. That kind of means the difference between our maximum and minimum temperatures is
19 degrees.
twice 19, right? As it would be. Where's the middle?
Middle? See, it goes up 74.
74. Right. Wouldn't the average yearly temperature be 74? How did I know that? I didn't draw a picture. How did I know that?
Even at the lowest point, it'll be 74.
If I were to draw this, right? If I were to draw it, I'm not going to actually be careful, but wouldn't you agree it's moved up 74 units? So it oscillates above and below 74 all the time?
Yeah.
So what's the average? That makes sense, and it would be. So the vertical shift is actually the average temperature, or the average of the function, because it stays right around that. Does that make sense? It's pretty interesting that we can find out without doing any work. On a non-trig function, that's a calculus question. You can't find the average value of a function, except for these periodic functions that stay right around the average. Other functions, that would be a little harder. so this one's a much more challenging problem. They don't give us the function. So it says in Chicago, the average monthly temperatures include 22 degrees in January, 47.8 degrees in April, 73.3 degrees in July, 52.1 degrees in October. On average, January is the coldest month of the year, and July is the warmest month of the year. Using only the maximum and minimum temperatures, find the function. So this one's a tough question. I have to write the function. I'm going to go at this pretty slowly. I'm going to do it step by step. Part 1, step 1. How would I find the amplitude? And this is where those notes you took at the beginning will be helpful. Wouldn't you agree that the amplitude would be the biggest and smallest subtracted from each other? That would give you. So if I take the top value and the bottom value, isn't the amplitude half of that distance? So I'm going to find the distance between the top temperature, which is 73.3, and the bottom temperature, which is 42. So for the amplitude, I'm going to do 73.3 minus 22. I'm going to do half of that. That would be my that would be the A value. 25.6. Right? That's right. So that's A. Any questions about how I found amplitude? Highest point minus the lowest point, divide that by 2. Does everyone understand why that would give you the amplitude? The next thing I'm going to find is the period. Well, really the B value, but I need the period to do that. This one's more just a thought process. How long is it going to take for the temperature to start repeating? 12 months. Everyone agree? 12 months. Then you're going to start over again, because after 12 months, you kind of have that. Then you're back to January again. So, if my period is 12 months, 2 pi divided by B would give me the period. So, what would be
12.
pi over 6? Why would it be pi over 6? Cross multiply, you have 2 pi divided by 12, which reduces to 5 or 6. Period is 12 months, and B would be pi over 6. So, does it make sense that on the last problem, I used pi over 6 for B? Any 12-month cycle is going to use pi over 6 for the B value, because of your time. That makes sense that they used that on the last problem. Any questions so far? I know A and I know B. And I need to know what else? I need to know the phase shift. Okay, and I need to know the vertical shift. I'm going to do vertical shift first because it's a little easier. Phase shift can be difficult. Sometimes you just see it as easy. So we'll talk about that. I'll show you both options. The hard way and the easy way. So let's do the vertical shift first. They called it C. How would you find a vertical shift? Which you already told me the vertical shift was the average yearly temperature. Wouldn't that be the middle of the highest and the lowest? If this is truly a sine function, which it may or may not be, but if it's truly a sine function, then the middle will be the average between the highest and lowest. So I'm going to average 73.3 plus 22. Notice I'm doing different things here and here. Okay, here I found the length between them and divided by 2. Here I'm finding the average value. And what do you get? Chicago is 47.65 degrees. Evidently. Looks like this is real data. I'm not sure I got out of this. Any questions so far? Now, if I want to write the function, I know everything except the phase shift. There are two ways to get the phase shift. Sometimes you can just see it. On this one, it tells you that January is the coldest month, right? So one option is to treat this like a negative cosine function shifted over to January. Does everyone know what I mean by that? That's a hard thought process because there's a lot going on in your brain. Does that make sense? Because we had to know what goes where and all that fun stuff. But it is the fastest way to do it. So I'm going to show you that way, and then I'm also going to show you the long, tedious way, but it's also good to know because sometimes our brains can't handle all of that at once. So January is the coldest month. It's at 1 unit, right? And so we're starting down at -1, 1 unit over. And so I could use a negative cosine function. And what was my amplitude? Cosine of pi over 6 times x minus 1 plus 47.65. Because I will never specifically ask you to find a sine function. If you can ever do that in your head, do it. It's the easiest way to make a trig function that models it. However, they did specifically ask me to use a sine function. And that would be very tricky to figure out where that crossed the x-axis. Does everyone agree? So this becomes a problem that I'm going to have to use some algebra on. Again, if you can do this, you stop there, that's your answer, I'm great with that. But there will be some that you can't see the shift. Do you know what I mean by that? You can't just see where it falls. This one we saw that 1 was the coldest month, we could move it right 1 and use negative cosine. So a more generic way to find a phase shift. And I am going to use sine this time since it asked me to.
Students, if I can have your attention quickly. Students, we still have a few students parking on campus without a parking tag. Starting tomorrow, students that come on campus without a tag will be assigned to morning detention. Make sure you get those tomorrow. Thank you.
So
Is it not supposed to be negative?
Oh, sorry. Yeah, I'm not going to make it negative. You actually could, and it would be equivalent, but just for simplification, I'm not going to. But yeah, you could make it. The thing I don't know is the phase shift. So I'm going to use algebra to find it. What? Go ahead.
You can take like January or something and plug in x's, whatever.
So you go.
Y.
Does everyone agree I could take the y value at January, what was it, 22 degrees in January? Have y'all done this before with linear functions to find b, to find the y-intercept? It's like that on steroids. It's a lot harder than that, don't get me wrong, but it's the same thought process. We will learn how to solve trig equations completely by hand at a later date, but I am going to walk you through this trig equation with a calculator. We'll do part of it by hand, but then we'll pick up a calculator. Subtract the 47.65. Everyone would agree that would be my first step. And just go slow with that is. 0.65? Is that right?
Yeah.
Okay. And then 25.65 sine of 5 or 6 was one way. Divide out the 25.6. to -1, you might, when does sine equal -1?
Yeah.
70 degrees, so 3 pi over 2. If you saw that, you could write that answer down. I'm going to use the calculator because this may be a number other than 1 that I can't figure out. The beauty of it is, even though we might get different answers, they will be equivalent graphs. Type. How do you undo things? How do you undo? Inverse. So you sine inverse of -1 in your calculator. It tells you -pi over 2. Is that equivalent?
Yes.
Yeah. If you had said 3 pi over 2, would you be right?
Yep.
Yeah. Either way works. So I'm going to do sine inverse of both sides. And I get -pi over 2. Again, if you did 3 pi over 2, you are absolutely right. I'm going to multiply by 6 over 5. So I get -3 1 minus d. -4 equals -d. So d is 4. And so my function would be 25.65 sine pi over 6 times x minus 4 plus 47. Don't remember.
47.65.
So that is a lot of work, but I got us a model for that trig function. Now, if you were in pre-calculus during their trig class, they might not do all of this work, and they might shortcut it a little more and always use the calculator. So I do want to throw out why I have you do a little more than they do. What field would require that you would need to be able to do something like this? Model. In meteorology or maybe engineering, if we take this to other things, right, other than just weather. And so, who are the engineers in the school? You, right? If anyone's going to be an engineer, it's going to be you. And so that's why we're going to go a little more, not just calculator. Okay. I have several more examples, which I'd like to wait until tomorrow to see the rest of the examples and just try some and then do more examples tomorrow.
Yes.
Yeah.
That way I don't hit your brain overload and then we can, it's the same stuff again. This one's sunrise, sunset times instead of temperature. So it's a little different. Obviously the period's going to be a little different because it would probably be something more like 24 hours or something like that. But we'll do it this problem tomorrow, that one tomorrow, and then we'll also do calculators. Your homework, this homework is not due until Friday. This homework is not due until Friday. It's page 264, 22, 30 through 40 even, 46, 50, 56, 62, 66, and a worksheet. The worksheet is the one where you'll get a problem that was long and tedious like the one we did in class. The ones on the in the bookwork aren't quite as tedious for the most part. If something asks you to use the calculator, I will teach you how to do that tomorrow. So don't try to do the calculator yet. I will teach you how to do the calculator tomorrow. On Wednesday and Thursday, we will be working on an in-class project, so you won't have in-class time to work on this. this will just be your homework those nights too. So this is due on Friday.
So 6 inches
Involved. Those are, if I remember correctly, those are the spiral review problems, and they'll be written with other things.